I think there are a lot of people who joined from my last session, which was on analytics using Excel. I'm going to link from the previous session to this session. There could be few slides that may repeat, and I've done that consciously for all the learners who could not attend the last session. So few slides, and the deck that I've created today has only 7 slides. Okay, but we're going to use these 7 slides over the next 2 days, because I'm going to do a lot of practical things today rather than only the bookish things. What I intend to cover in the session in the next 2 days are outlined here. So we'll start with understanding data requirements, because that becomes the crux of any analysis, analytics, or even narratives that we want to pull out of our data. We'll understand data structures. This is a repeat from the last session. We'll look at data preparation, and then we will start finding stories in your data. Now, from this point onwards, I do not have any slides. I haven't prepared any slide. All the next topics, extracting meaningful insights, deciding the outputs, different data visualizations as per your story, descriptive outputs and graphical outputs are all practical things that we're going to learn. So you won't find anything on those slides. So I want to make the expectations very, very clear today. Okay. As Pratibha ma'am said, stop me anytime in between you think you have a question, unmute yourself and shoot your question, and I will be happy to take those questions. You want to type in the chat box, feel free to do that. At some point in time, I'll get it to the chat box and see if there are any questions, and I will answer them. Right, let's start. To understand data requirements. Now, we all are too much bogged down with a lot of things like what is data. Okay, so we may have answers to what data is, but not all the time. Sometimes we make mistakes in identifying or recognizing the data that we need for the outputs that we want to generate, because data is available everywhere. But is that data meaningful enough for us to make head and tail of it? Okay. Now, what the data requirements normally depends on the outcomes that we want to achieve out of this data. Some of these expected outcomes, this is not a holistical list, but with my experience of working as a data analytics myself for 8 years with this organization, I've learned that most of the time the outcomes depends on the audiences to which we are going to share the outcome of this data. These could be internal stakeholders or it could be external stakeholders. Now, what we do with the internal stakeholders will be little different than what we share with the external stakeholders. So for each of these audiences, we'll have a different data requirements. Now, it could also depend as per the leadership hierarchy. If I have to send some outputs of the data, if I may call it reports. So if I have to share these reports with very top senior leadership within the organization, I will not send so many slides or so many data points. I will only give them a summary so that they can have a broader view of what is happening within the entire organization. But if this data has to go to the last leg within my organization, maybe at a supervisor level, so that they know what their team is doing, how each person performance is happening, what are the different things that each person from their team is doing, then probably I will have to have more details, and hence my data requirements will be different for those kinds of audiences. Now, data requirements will also depend on what kind of data I have. Is it financial data? Now, financial data will also comprises of direct impacting financials or indirectly impacting financials. We look at few of these examples. Okay, so I'll help you with examples. Then we could also have reports that we may prepare on some operational matrices. Now, what are operational matrices? Most of the time when we when we're doing operations, we're doing it for somebody else, or even if we're doing it for our own organization, then there is some contractual binding that we have to achieve. And so day on day, week on week, month on month, we are contractually bound to give those reports to our clients or our senior leadership. This is what we call matrices. Some of the matrices that most of the operations use, something called known as an AHT, or an average handling time. TPH is transactions processed per hour, transactions processed per day, time to process the transaction, accuracy, NPS, CSAT, and there could be many more. These are few common ones that most of the operations normally track. There could be other operational KPIs. Those are only for our internal controls, for our internal leadership teams at a supervisor level or even at a manager level. They would want to look at what is the progress performance on those KPIs, and they define those KPIs. Some KPIs that most of the organizations will look at is the headcount report, number of seats that people are utilizing, because every seat is also a cost. It is a direct cost. Attrition reports, absenteeism reports, or it could be any other hygiene factor that they want to look at as a operational KPI. Those are not contractually bound, but they know that these KPIs do impact the operational matrices. So depending on what kind of an outcome am I looking at or is desired, I look for data requirements. I pause for few seconds if anybody has any comments, inputs, questions on this. Understanding data structures and data preparation. Now, knowing your data is very important. What kind of a data am I anticipating to collect? Now, why this is important? Because the tools or the graphical outputs that I'm going to use, or the graphs that I'm going to draw, needs certain kind of inputs. Not every data can be used to give all different kinds of outputs. So each output as a graphical representation would require a certain type or kind of a data. So it is important to know what kind of data are you anticipating, so that you can plan, prepare your mind as to what tools you're going to use, and are those tools good enough for you to give your story from your data. Now, sometimes you may need to change the data structure. You have an A type of a data, say for example, you have a text kind of a data, and you cannot, do graphical outputs only from the text. So you may have to change the data form or the data structure from a text to somewhat numbers, so that you are able to make head and tail of it, or you are able to do some visualizations from that data. Now, knowing your data structure will also help you prepare your data to get inside story. And then you may be required to add additional columns a lot of time, and we'll see practically how once we have a data, how adding additional columns of data or additional sets of data, or creating new data sets from your existing data, changing your data structure and adding new data to your data really helps you achieve your outcomes. Sorry. Then and a lot of time, when you collect data, it may be because of some data collection errors that the data is not cannot be used in the form it has been collected. So you may have to revalidate your data, you may have to redesign your data, or you may have to do few different things with the data. We'll also look at an example of what I mean by all these. And sometimes you may not know the output, because it's the first time this operation is running. It's the first time you have got the data. You may have few inputs from the senior leadership as to what they want to see. But as a data analyst or as a data scientist, it becomes your prerogative to get a deep dive into those data and see what else can you get or what else can you gather, or else can you display from what data is showing, so that you can extract some meaningful outputs out of it. Then this is a repeat from the last session, but still I'll spend couple of minutes on this slide and the next one, so that people who did not attend can understand what we understand by different type of data. So data is nothing but it is a collection of facts, which is number, words, observations, other stuff. Data can be of two types: qualitative data and quantitative data. Now, qualitative data is something which is not easy to measure, because it always tells you about the quality of the measurement or quality of the subject from which the data is being collected. It's because it is describing something, or giving an information about something. Now, on the other hand, the quantitative data is something which is more in number forms, numerical forms, right? So broadly, if you look at the bifurcation, one side you have the qualitative data, the other side you have the quantitative data. So qualitative data is something that gives you the quality of the data. It was great, fun, you are smart, you are handsome, those kinds of data sets. But the quantitative data gets further divided into two streams. One is called discrete and the other one is called continuous. Let's look at some broad categories of discrete and continuous data, what these two are. So before that, we have this qualitative and quantitative data. So whatever we have just discussed, summed up on this slide. So qualitative data, where data collection is very unstructured, because those could be some statements. It always asks why that happened. It cannot be computed at it is non-statistical. So it is not numbers. And it develops initial understanding and defines the problem. But the quantitative data is, the collection is structured somewhere. It is also about how much or how many. So it quantifies the things. It is statistical and is about numbers. And it recommends a final course of action because you are able to make some head and tail from this data. How the quantitative data gets segregated into two streams, discrete and continuous. So we'll talk about the continuous first. So continuous data is something that is collected using a measuring scale or an instrument. So always using any measuring scale or an instrument, which is continuous data. So example, anytime you stand on a weighing scale and you get your weight, that's a continuous data, because I'm using a scale or a gauge or an instrument to do that. Anytime you measure your height, you use a scale, which is your measuring tape. So it is coming out of an instrument. You're driving a car, you have a speedometer, it gives you a speed. That's a continuous data because I'm using a gauge. When you get your tires inflated, they uses a gauge which gives you the pressure in the tire. That is a continuous data because it is coming out of a gauge. Time that you tell everybody or you ask from somebody is again a continuous data because that is being read through a gauge or an instrument. Now, any data which is not coming out of an instrument goes to the other side, which is discrete. Discrete has so many categories, and different data scientists or different statisticians will or have divided or categorized the data as per what it suits their requirement. This is something that suits my requirement, or more of doing statistical analysis and validations. I prefer going this direction of data subgrouping. So discrete data, I know there are 5 types of discrete data, starting with count data. So binary, count, percentage, ordered category, and unordered category data. So these 5 different kinds of data sets that we have in the discrete. Anybody who did not attend my class and want me to spend a little bit more time explaining what these data sets are, I'm more than happy to do that.
Yes, please.
Okay, sure. So let's look at the discrete categories. So binary is 0 or 1. Only one outcome out of it. That is a binary data set. Mostly computers uses a binary system, 0 or 1, right or wrong, yes or no, okay, not okay, is all binary numbers. So that is one of the categories. Let's look at the count first. So whole numbers, all whole numbers fall in the count category. What is count? As per the definition, it's counting numbers. Counting numbers start from 0, goes till infinite. There is a property of a count data. There's one property. Count data can only help you count what has occurred, but it cannot help you count something which has not occurred. Okay. Say for example, if I make you stand in front of your house and I ask you to count all the cars that went by and that were black in color. So you can only count those cars that will pass from in front of your house. But you will not be able to count all those cars that never passed from your house. So which means that count can only help you count something that has occurred, but it will not help you count something that has not occurred. So that's a property of a count data. Then we have something known as a ordinal data. Ordinal data. Ordinal means in some order. And ordinal data gets divided into two streams: unordered categories and ordered category. Let's look at what is the difference between these two. If I am collecting a data and counting what are the top 5 colors that most of the people like. So I go out and do a survey and ask what are the top 5 colors you like. So the first person gives me a list. Then I go to the second person and then I ask this person what are those top 5 colors. Then I go and then I collect, maybe 10,000 or 11,000 records like this. Now the data that I have collected is called an ordinal data, but it has got no order because those 5 colors are those top 5 colors, because I did not ask out of the 5 which one is the first most preferable and which is the last most preferable. Because the moment I do that, then I move from an unordered ordinal data to an ordered ordinal data. So most of the time for statistical analysis, we make use of the ordered category other than the unordered category. I'm not saying this doesn't have a use, it also has a use. Most of the time we go with the ordinal category. And one of the examples that I can give you of an ordered category data normally that we use and analyze are your rating scales. The customer satisfaction rating. Even you may have participated in some surveys from organizations who may have come back and asked you, can you rate your experience on scale of 1 to 5? So whenever you are rating 1 to 5, where 1 means the least and 5 means the best, that's when I say I am collecting a data which is ordered ordinal data. So that's one of the discrete category. Then we have this last, which is called the percentage. Percentage is sort of an exception in the discrete category. The reason why I call it an exception is because a percentage is not a straightforward data set. This data set gets derived. So this data set gets derived out of two data sets. One on the numerator and the other on the denominator. You have to have two, numerator and denominator, to get a percentage, or a better thing that I like to call it, I call it proportions. Because not every time you will have 100 as your denominator. Okay. Depending on what your numerator and denominator is made up of, decide what is the outcome going to be. Now let's say if I'm saying that I counted 230 cars that passed by my house, out of which 80 cars were black in color. Out of which 80 cars black in color. When I do this division, I get a proportion, right? That's called a proportion. You multiply by that 100, you get a percentage. Now, I have a numerator which is made up of count. These are counting numbers, right? It could be either 0 or 1 or any number, but in this case it is 80. And then the denominator is also count. Total cars, again counting numbers. Okay? So when you have a numerator which is discrete and you also have a denominator which is discrete. This is discrete, this is discrete. The outcome becomes discrete. This proportion becomes discrete. But if either your numerator or denominator, either of it, is continuous in nature or has a continuous data type, then the outcome becomes continuous. I'll take an example. I say that I did 20 tasks in 8 hours. This is also proportion, right? Which will give me what is the average time I took to complete one task. So if I have to get the time for one task, I will say how many tasks I completed and how much time I took. Just look at what numerator and denominator is made up of. This 20 is numbers, which is count, which is discrete. In the denominator, I have time. Time I know has been collected using an instrument, which is my watch, and hence this is continuous. So this is continuous. So here my quotient is made up of discrete numerator and a continuous denominator. So the outcome becomes continuous. This is no longer discrete. Similarly, the third case could be both my numerator and denominator are continuous. So distance traveled on time taken. Okay, so distance traveled comes from an instrument, time taken comes from an instrument. So both are continuous. So continuous by continuous, outcome becomes continuous. That's why I prefer putting this as an exception, and I need to look at what my numerator and denominator was made up of for me to decide whether should I keep it this side of the group or this side of the group. I take a pause for a few seconds to see if anybody has any questions here. Right. So now with this, what I'm going to do, I'm directly going to jump into a case study. Now I'm going to spend the rest of the time that we have on this one case study. I partially solved this case study for all of us. I'm going to teach you what I did, how I did. I've got in total I've got 3 case studies here. Okay. Now this is partially solved. When I say partially, almost 90% of it is solved, so that you can taste how the outputs may look like. This is complete. This is not at all solved, but we are going to solve this together. So tomorrow we are going to take up this case study. I will also make this case study available for all of you before the class, so that you also can have a look at it, look at this case study, and we're going to do it together. I will do this only if you promise me that we are going to solve this together. And then I'm going to give you a third case study. This is totally unsolved. I'm only going to give you hints of what this case study is all about, and this is a takeaway that each one of you is going to get to solve on your own. This is not very complex, but there is a lot of learning in all these three case studies. All these three case studies are real-time case studies collected from real-time processes and operations. Okay, I've masked a lot of things, I've hidden a lot of things, but you will not be able to make head and tail of it. But then just to tell you, these are not cooked up data sets. These are all real-time data sets that we have collected for an analysis. Okay, so the first case study, I've given a title, time taken to process a claims payment. I'll give you a background of what this is all about, what this process does, and what are the different outcomes that are desired. And then there are some outcomes that were not even known, but as data analysts, we created certain outputs, and we're going to create more outputs today. We're going to deliberate on what else is possible once we learn and understand, and then we're going to add those outcomes. Then what happens when you create certain outputs? There are two ways of presenting these outputs. One of the way is with that Excel file itself, okay, and the other is to create some kind of a presentation and then present your outcomes, what we call dashboards. Okay, so I'm only going to touch base on a dashboard, what a dashboard is, how it looks like, what is the structure or could be the structure of a dashboard. I have a following class next month, in the month of June, where I'm going to talk on how do we create a dashboard. Okay, so in today's class, I'm only going to touch on the dashboarding part, but we learn how to create dashboards in more full length in the other session that comes in the month of June. All right, let's move forward here. This is how this data structure may look like, but that's not only thing I'm going to show you. I'm going to just close this, and I'm going to open my set. My first case study. Okay, so let me explain you what this data set is all about. So this is an operations that is run to make payments for certain claims. Like if you are in an organization, typically there are two types of claims in this organization where we collected this data, where there are two types of claims that people or the employees normally file. One is a medical claim with their medical bills and all of it, and the company reimburses. And the other one is a travel claim. So if there is somebody who is traveling and is allowed to make a claim, then he can file a claim. So we have collected some 100 records from 4 zones where we have these offices: south, east, north, and west. Some 100 records on claims, and there are two types of claims: medical and travel claims. This is something that the people were collecting. The moment the claims office receives the claims, they stamp. They put a stamp on the claim when the claim was received and give a claim number. We have the claim numbers here. We have the date received, and they will also record the employee number of the person who has submitted the claim, just for a cross-reference purpose, so that they are able to reimburse you to the right person. So they will collect the employee code. They will not collect the names mostly because the names may repeat. They will collect the employee code. Then they also keep a track when the claim is received. It is processed and sent for approval to certain hierarchical levels depending on what is the amount on the claim. Okay, so it may go to one approver, or it may go to multiple approvers depending on what is the amount of claim. So they also record that what is the time when it is approved. Then they also track how much time it approved the claim. And they will also record the moment the claim is paid back to the employee, and on what date the claim got paid. And then they also track from the time the claim was received to the time it was paid. They also calculate the number of days. Then they also record the amount on the claim. If the claim was delayed, what is the reason? Who was the account officer who worked on the claim? What was the day? So these are the data sets that the team is collecting. Only this data set. So, and this has been, a process, but nobody looks at this. This is only for keeping records in the claims department. But one fine day, what happens? The employees started complaining that the claims department is taking too much time to process our claims. They're not processing claims on time. So, a lot of complaints were received. So then, a data analyst was appointed to the claims department to do the data collection and some initial analysis before that analysis can be passed on to the senior leadership. And then the senior leadership would appoint a Lean Six Sigma professional to look at what is happening and what are the, how can we improve this process. So the data analysts, they asked that if we collect some data, and they said yes, we do collect the data. So they provided this data. So they provided this data analyst. Now we are the analyst. We have got this data and we have to make head and tail. We have one desired output out of this data, which is required, because that's the complaint that people are saying, that you're taking too much time to make claims payment. So when it comes to too much time is a qualitative data, not the quantitative data. Now this too much time has to be quantified. So we went back and so we went to the claims department and we asked them what is an expected time that people look for the claims payment. And they said 15 to 18 days their claim should be paid. So hear me, you know how I'm putting the story behind, trying to extract things. They're saying that 15 to 18 days is when the people can expect their claims payment. So those data points are there. Now I have, as a business analyst, I have to do a little deep dive into what is this data, what is the total time that we're taking, is there anything that, or are there any clues that I can bring out of this data so that I can tell what is happening. So I decided to add a lot of columns here. One, I added a target. Because at 15 to 18 days, I took the extreme outer. I could have taken 15, 16, 17 or 18, but I wanted to start with the 18 first. Okay, the outer limit of it. So I put a target here. Then I said that let's look at if anything related to the day it is received. Does it impact anything from the day when it gets approved, anything on the day when it gets paid? So maybe, if it is approved on a Friday, it might get paid only on a Monday, not on a Sunday, right? It may hamper. So I wanted to do all these studies, so I added few columns on my own. Right? Then what I did, when I started making sections of this data. So I ran few pivots. What all pivots I ran? First of all, I wanted to see that how many claims are we receiving for each zone. Is the time that I'm taking for each zone is same or not, or least similar, if not same. So I do a pivot. So how I did a pivot, I'm going to redraw every pivot that I've done so that you also understand how I've done this pivot. So now to run this pivot, I go to insert the table. I need to select the range. Range is here. I select all of it and then I say put it on the existing worksheet. I get my pivot. So I took the zone and I dropped it in the row, and then the count of the zones. That is what you see the first pivot. So from out of the 100 claims that we received 26 claims in the east zone, 21 in the north zone, 25 in the south zone, and 28 in the west zone. So now looking at the numbers, it doesn't seem too much of a variation here, right? It's not too much difference, 21 to 28, which is almost comparable, if not very close. Not too far apart. I mean, 5 claims in one zone and 60 claims in one zone. That is not the case. So that's the first extract I wanted to see. Then I wanted to see if claim types that we're receiving, okay, are any different. So then I drew my second pivot. How did I do the second pivot? Since I know that my raw data is the same, I need not draw the pivots all over again. All I can do, I can copy the previous pivot and I can paste it and I can change. Okay? This time I don't need the zones. This time I need the type of the claims. Then the count. And I will remove the blanks. So this is also comparable. So it doesn't say that I'm receiving more medical claims than travel claims. Okay, this doesn't say any of this out of it. So this is another extract that I learned. Now I want to see that for each zone we have a difference between medical and travel claims that we receive. So I will again copy this and paste it here, but I now with the type I need the zone as well. So I have this here. Each zone I've got total 26 claims. 26 claims. Out of these 26 claims, 10 claims from medical and 16 claims from travel. Similarly, in the north zone, I've got 10 and 11, 11 and 14, and 18 and 20. West zone, maybe I've got a little bit of a variation. The medical claims are much more than the travel claim. That's okay. But that's a story that I need to capture. I got my third story. For each zone, what are the number of claims? This is about the numbers, but the concern area is about the time. The concern area is about the time, which is this time or the days that we are taking to make the claim payment. Is to right. So now I need to also understand any relationship or how much is that time that I'm taking. Again, I go back to my zones. I could have done it in one pivot, just for your understanding perspective and my teaching perspective on certain basics things. I'm doing so many pivots so that you understand what I'm doing. But at the last, I'm going to show you how we, how can all this be done in one, so that you are able to make some head and tail out of it. Then I did for each zone, what is the average time that I'm taking to process a claim. So how do I get the average time here? I insert a pivot, I select a range, okay, and I draw a pivot. Now I select the zones. But now this time I'm not going to select the zones again here for counting, but I need days to pay. So I take the days to pay and drag it in the value. Instead of counting, I'm going to click here, value settings, and I'm going to select average. Right, so on the average, I got the average. I'll move this average to 2 decimal places just for ease of my calculations. Okay. So 18.96 days we're taking to pay a claim in each zone, 21.24 days. 21.24 days in the north zone, 20.32 days in the south zone, and 20.21 days in the west zone. Now, even if I take a target of 18 days, which is my outermost, none of my zones is complying to the average time. Okay, so that is very much clear from here. None of the zones, but the most of the time that is taken from the north zone. That's another insight that I got. Okay, so north zone is taking most of the time and east zone is taking least of the time, but none of the zone as an average is at the target days to pay time. Right, so that's another insight. Now, while I look at the average days to pay, I thought of also looking at if my days to approve, okay, has got any relationship to days to pay. So I drew another pivot. This time, instead of days to pay, I took days to approve side by side, which I have already done, but I can draw it one more time if you want to. All I need to do is just copy this here and select this pivot, and then from days to pay, I can select days to approve, and then click here, value field setting, and that's average. Okay. Looking at these 4 numbers, it actually gives you a little bit of a story. See, let's observe. East zone is taking the least time to approve and is also taking least time to pay. Okay, but it is not true with the other zones, because west zone is taking most of the time to approve, or maybe it is equivalent to the north zone. If I can remove the decimals, so this will show 14 and 14, this will show 13 and this will show 13. Okay, so 2 are on 13 and 2 on 14, so not too much of a difference here, but seems maybe some kind of a relationship here, which I will park as of now, but it has given me some insight. So when I looked at this data, it has given me some insight that days to pay and days to approve may be linked together. So we'll park it here. So that's another insight that I got. While I'm doing this, I thought of another question. Do we have a target on days to approve? Okay, is there a target, or anybody can come and approve and just go, and then it is a pressure on the claims department to quickly release the payments. Maybe on the 17th day we approve it, claims department only has 1 day, and in 1 day they have to make the payment. Okay, so we want to look at that aspect as well. So if there is no target, we will propose a target so that at least it should impact the days to pay, because that is a problem area today, because employees are complaining about how much time, the lot of time is taken. A lot of time is taken to make the claim payment. Just 1 second. Yeah, sorry about that. Okay, so that's another insight that I got. Then another cut which I wanted to see, that how much is the average days for medical and travel claims, which doesn't seem to be too off, almost similar, 13.55, 13.29. So this is another insight that medical and travel claim doesn't take a different time for approval. And then I can also look at how much time it has taken to payment. So instead of these two, okay, again, medical claims are taking little bit more time than travel claim, but not too much. But one thing is very, very clear, that either medical or travel claims, they're not able to stick to the target timelines, which is 18 days. This is 20.76, this is 19.53. So now till here, when I look at this data, till here I see a problem. I actually see a problem that whatever people are complaining, they're right in their complaints. This is from a very holistic point of view, just to do little. This is not too much of a deep dive, but just looking on the top of the ocean, I'm able to figure out at least few things here. Okay? So there is a problem. The problem is not inclined towards any zone on or any claim type. This problem is in totality, in entirety. There is a problem. So we have to go and do more in depth as to what is happening. Now, what I did as a separate, then I started plotting in one single pivot. So I plotted the zones. Alongside the zones, I also plotted the type. So which is east zone medical travel, north zone medical travel, south zone medical travel, west zone medical travel, and all these numbers. So that were there on one separate pivot. Okay. Then there is another way of doing plotting, so where for each zone, what is the number of claims and what is the average days to approve. I could have also added average days to pay right here in the same pivot. Average days to pay, so that I can have one holistic view of it. So 26 claims, average days to approve is 12.92, average days to pay is 18.96. Okay. Then I also wanted to look at, because I added another set here, just to see that if the days to pay was okay, not in terms of comparing to 18 days, but for each claims, not now as an average, but for each claim, whether it was paid within 18 days or not. So I plotted it for all the 100 claims here, all the 100 claims. And then on all these 100 claims, I wanted to see how many percentage of the entire claims are okay and how many are not okay. And here comes another insight that out of the 100 claims, 87% of the claims are not paid on time, and only 13% of the claims are paid on time. So this problem seems to be very big. Only 13 claims out of 100, which is 13%, are paid well within 18 days. Now I could have also gone and did another step, as these 13 claims, were they paid on the 18th day, were they paid on the 17th day, were they paid on the 16th day, if I would have done that as well. Okay? And that's another insight that you could have got, that out of these 13 claims, how many claims are paid on the 18th day, 13th, 17th, 16th, 15th, or even lesser days. Okay. Okay, and similarly, so this was days to pay, okay, not okay. And I also wanted to look at for each zone, what is, how many claims are paid on time or not on time, and it repeats the same story, because out of the 13, if this is only 13, then this number is also going to be vary a lot. So east zone only 4 claims, north zone only 2 claims, south zone only 2 claims, west zone only 5 claims were paid on time, which comprises of 15 claims out of the 100 claims that are paid on time. I'll pause for a few seconds here to see if what I did right now makes any sense to you. Any questions that you have, any other view that you think we can drive out of this data. Okay, let me put it another way. Are you liking this session? But believe me, but if you understand what we do today and tomorrow, okay, you will be able to do a lot of good dashboarding and reporting if you are in that kind of a role. If even not in that role, you can do this reporting for yourself at home. You can create your own budget reports, outputs, and dashboards for yourself. Okay, anyway, I'll move a little bit more forward. So these are, some steps that most of us are going to take when we get the data. This is not going to come in one day. I haven't learned it in one day. It comes over a period of time. It comes with practice. It comes with your knowledge on any kind of an operations process. It comes with what are the outcomes that people are desiring. It comes with lot of analysis that you may learn before you even attempt this. So we started these sessions with very basic Excel classes, 4 days classes, where we taught these basic things, and then we are now moving on to more complex things. So watch out for the other classes when we plan it, when we get it on the public domain. Make sure that if you don't understand how we've done these pivots and all that, so maybe those classes may be more beneficial for you to get started, because we start with right from scratch of understanding Excel and then building on our knowledge in the 4 sessions. Okay, but for people who know this subject and they want to learn, I need a feedback from you guys, that is this something that you are understanding, or do you want me to add more flavor to it, or you want more explanation on how did we arrive to all these things? I'm more than happy to take these questions. Now these sessions are not only one way I wanted to do, okay, just a download, but the idea is to help you understand this subject. Even if you are able to pick 10% from these 4 hours, I think we have made a day. But make sure that you pick those 5, 10, 20% out of these sessions and make use of them, because only when you make use of these, you will be able to retain this. Right? Making sense?
Yes, sir.
Yes, sir.
Fantastic. Okay, so we've done some basic things. I've just spread it out on this entire worksheet, and I've done it intentionally uh, because this is only a learning session, a learning moments. So I wanted to show you, how what are the different kinds of data cuts that we can do to start getting insights from it. Now, what we then can do is to get certain statistical outputs. Okay, some statistical outputs. Let me see if we have a target for this to approve. If not, can we set a target? So we'll look at if we have a target for days to approve for the people who are approving it. Do we have a target for them? And if we do not have a target for them, can we set a target for them so that my days to pay is achieved? Okay, so we'll also see how we do that. Now, I tried to plot certain statistical outputs from these data. Now, here the data types or knowing the data types is important because that is going to help me design or define what are the statistical outputs I can get out of it. Okay. Days to pay, I know it's a continuous metric. I can get all these. Now, how did I get all these things? I'm just going to delete. And I'm going to show you how did I get this. Descriptive. So this is called descriptive analysis. Now to get the descriptive analysis, you need this here under the data. You have this data analysis. If you don't see this data analysis here under the data tab, then what you should do? A lot of time you will not see. This is not an option that comes by default when you install Excel. But this has to be enabled. How do I enable this? To enable this, I go to File menu. I go to Options. Under the options, I go to Add-ins. Under the add-ins, I look at Excel add-ins and I click on Go. So I need this analysis tool pack. Only this. I selected 3. You only need this analysis pack. You should check this if it is not checked, and then you click OK. So the moment you will click OK, you have to close Excel, open it again. Under the data tab, you will start seeing this data analysis. Okay. Now what I'm going to do, I'm going to click on data analysis. And then under the data analysis, you will see all these options. A lot of options here. Right now, I need only descriptive statistics. I click on descriptive statistics. It is asking me, is our input range. I click on this red button and I select this entire range. I click back. Do I have labels? Yes, I do have labels. This is my first row. Where do I need the output? I need the output right here. In my output range. My output range here. And just click OK. Nothing else. Sorry, statistical summary. Let's click and then click OK. So you get this. This is descriptive statistics. Now what this is telling you, days to pay on an average is 20.13. So the first problem starts here because we are trying to achieve 18 days. But overall for 100 claims across the zones and across the type, is 20.13. Don't worry too much about standard error here. The median time to pay is 20 days. The mode is also 20, which means all the three these standard tendencies are above 18 days, right? So you definitely see a problem. We also have a standard deviation of 4.44. One way to reduce this time is also to influence the standard deviation, but that work will be done by a Lean Six Sigma professional. When I do my bit of analysis and my graphical outputs, I'm going to pass on this data to that expert, and that expert is going to look at what is causing this variation and how can then influence this variation to reduce this time. Okay, and the minimum time that any claim took was 8 days, and the maximum time the claim took was 32 days. So here is also a problem. From 8 days to 32 days, so there has to be some explanation on this variation. This is huge. Right, so that's from days to pay. And I also did some descriptive analysis on days to approve. Okay, so I went to data analysis, descriptive statistics. My input range is different now. My input range is this. Labels, yes. My output range is also different. This time, this is not C1, but this is H1. And then, okay. So it gives me the descriptive data. Mean days to approve is 13 days. The median and mode of 13 and 15 days. So most of the claims are taking 15 days to approve. As a median, 13 days. As a mean, 13.42 days. Again, there is a variation. And this variation is because the minimum time a claim approval took 6 days and the maximum time it took 22 days. Now, how on earth, if an approval takes 22 days, I will be able to pay the claim in 18 days? So there are more problems, which means days to approve. This is an inference I can derive looking at these statistics, that days to approve is actually influencing days to pay. Because I'm taking more time to approve, this being the next step, I'm definitely taking more time to pay the claims. So my focus should not be here, but my focus should be here. I need to present this. My role right now is data analysis or the data analytics is to gather these insights and provide these insights to the senior leadership or any audience who may be interested in knowing what is happening. And I also wanted, because I see a relationship that days to approve and days to pay are definitely linked. The more time I'm taking to approve, the more time it will take to pay. So I wanted to also do a relationship between days to approve and days to pay to justify my hypothesis. Okay, so now to justify my hypothesis, I will run something known as a correlation. Are these two connected anyway? Okay, so what is a correlation I can run? I go to data analysis. I go to descriptive statistics. Not this time. I will go to correlation. Okay. So it is asking me input range. This time I will have to select these both as input range. Labels in first row. Output range. Output range is this. Okay, so I get some output. Now let me help you understand what this output is. So we are not interested in days to approve to days to approve. Okay, so we can disregard this. We can simply disregard this. I don't need days to pay to days to pay. I can disregard this. I'm interested in a relationship between days to pay and days to approve. So days to approve and days to pay, relationship coefficient is 0.86. Now what does this 0.86 actually means here? 0.86 means that is this relationship very strong, medium, or is no relationship. Okay. Now there is a rule of thumb, and this is something that we all have to mug up. There is nothing to understand until we want to get into the in-depth of the statistics. But it is said that if this number that we got, which is called relationship coefficient, this number is 0.8 or more. Okay, 0.8 or more, then it is a strong relationship. If this is between 0.5 and 0.8, which means less than 0.8, not exactly 0.8, but anything less than 0.8, it is called a medium relationship. But if it is less than 0.5, then we say there is no relationship, or very weak relationship. Okay, no relationship or weak relationship. This is a rule of thumb. Here in this example, my coefficient is 0.86. That means the relationship is really strong. That means this days to approve really affects the days to pay, and somebody has to do something about it. Either you make a target for days to approve for the approval people, so that they approve within those days, and how much both those days should be. That is something that my expert is going to come out with. That how much is the days to approve? If it is 10 days or 8 days or 7 days, then I will be able to achieve my 18 days to pay. Okay, that an expert is going to do some more in-depth statistical validation and analysis, and is going to tell us. One side of the story, which as a data analytic I've got, is that I've got a strong relationship. So which means this really impacts. I could have done another relationship that is the amount of the claim, okay, has got anything to do with the days to pay. I can do this analysis and also see if amounts impacts or not. Okay, so let's see if it impacts or not. Okay, so my output range is U. Okay. So I get my statistics. So I'm not interested in amount to amount. I will discard, and I'm not interested in days to pay. I can disregard this. I'm interested here. Now here days to pay an amount, value is 0.045, which is less than 0.5. Days to pay an amount is 0.45, which is less than 0.5. So which means they're not related. So one thing, that any amount that comes on the claim, don't need to worry about days to pay. It is not going to impact. So we've done just 70% of what we intend to do. So this is only some statistical outputs that I generated to see if this data can give me some story out of it. But out of what we have done, we've really unearthed some stories out of it. One story, a part of the story is that none of the zones or none of the claim types has got any different number of claims that were given, and the time that these claims are taking are also almost same. One part of the story is this, that the problem is something else. Okay. Then we also looked at if days to pay is any different, and we observed that days to pay is also not very different. And we did multiple iterations, multiple data point, data sets, multiple dissections of my data, and it all revealed the same thing. When we did this part of the analysis, it did not give me too much of insights, but only part of the story that days to pay is taking more time, days to approve is taking more time, none of the zone is responsible, and none of the claim type is responsible, none of the interaction of zone and claim type is also responsible. So not much out of this. When we started looking at the statistical part of it, some few statistical parts, it did reveal that there seems to be some relationship between days to pay and days to approve. Okay? So if I take more time to approve, it will take more time to pay. And we also qualified that assumption by doing some correlation analysis. So this definitely gives some interesting cues of how to improve. That's not my role. Okay, so let's be very honest on what roles are we doing. My role is not to improve this process. My role is to give insights, find out the stories from this data and present as it is, not as I want it to be. Okay, so let's be very clear here. I'm not going to suggest any improvement. Okay, then I can't present only these numbers, right? These numbers make no sense for people who don't like numbers or who may not be able to make any head and tail of these numbers. So I definitely need some graphs. And one second, one of the graph is, I just delete it. So one is that, whenever I do a correlation, I can draw a graph called XY scatter plot. Okay, which is a graphical representation of what we just done here. How do we do that? I select this, select these two tables that I used for correlation. I go to insert. I go here, scatter plot. So scatter plot. The scatter plot is, let me explain what scatter plot is. Spend just 5 minutes here. Scatter plot is basically an XY relationship. So we all know whenever we draw a two-dimensional graph, this axis which is here is always your x-axis. This axis that is here is always your y-axis. Okay. So every graph, this will be true. This will be x, this will be y. This one dot that you see on this graph is an interaction point of x and y. First point here is 14 cross 20. So 14 on the x-axis and 20 on the y-axis. It is somewhere here. 14 cross 20, you see? 14 cross 20. This is this point. First point. And similarly, all the 100 points are drawn like this interaction. 17 cross 32. 12 cross 24. Each point is a cross. Now, if these dots that you see on a scatter are very close to each other, this depicts a strong relation graphically. Okay, I can plot all these numbers right here on the graph. All I need to do is select this graph, go to the design and go to layout. I will search for layout 9. Layout 9. Fantastic. So it gives you, ask this a little bit. See another dotted line here, small dotted line just going right here. This is for this chart. This is called the trend line. This is a linear line for these dots. Okay, so this is basically, and this equation that you see here, right here, so which is I equals mx plus c. Okay, mx plus c. This is nothing but this is a linear equation of a line. Okay, where y is the output, x is the input, m is called the slope, and c is the y-intercept. That is what this line is all about. This line. This is called a regression line in the statistical terms. This is called the regression line. That's the equation. These scatters and the regression are also used as predictive models. Okay, so you can predict your model, but not with 100 points. For this kind of data predictions, you need lot of data, big data. So how do I predict? I know y is my output always. So understand this, y will always be your output. Y is the output, and x will always be the input. Okay. Y is also called dependent variable, and x is called independent variable. There can be more than one x that may be influencing my y, which is dependent. Y is always dependent on x. Here in this case, this is my x, which is days to approve, because this is the input. This is impacting my output, which is days to pay, which is my y. So if you look at this equation, y is equal to 1.1006x plus 5.3596. If I use this equation and I can change the x variable to find what is going to be my y variable. Let's take an example here. Okay. So let me first take these numbers. Here I will put my x, and then here I will put 5, 3, 5, 9, 6. Okay, so we'll put this into the formula. This is this multiplied by this. I'll put that in bracket plus this. Okay, so because this is there's nothing. So let's say if my days to approve is 10 days, my days to pay will be 16.36 days. That is the predictive model that I can create. So this is one of the models that I can do using Excel, which we are actually going to talk in one of our upcoming sessions in the 3rd week of June, which is models, tips and tricks Excel. Okay, so here I can model and say at what target should I fix my days to approve so that I'm able to move my days to. If I have to achieve 15, probably I'll have to fix it at 8. If I'm able to approve my claims in 8 days, I will be able to pay my claims in approximately 14 days, plus minus whatever that is. Okay. I have to consider the variation part as well. So 8 plus minus something would come. But then again, I'm saying this is not my role. Unfortunately, I've got both the roles, so I just go out and start teaching this, but then that's fine. This is a predictive model. So to better this model, we will keep with the increasing time period, and this model is going to improve. So when I reach 1 million data points, my model accuracy may become 98, 97%. It means that I will become God. I'll say, if tell me how much time you took to approve, I'll tell you how much time it will take to pay. I'll play God. That is how these predictive models help. Okay, so this is all statistical with one graphical output which I did. My dashboards cannot go with numbers, with only numbers. This raw data and these numbers. Nobody will be able to make head and tail other than me myself. So I need to think of a lot of other graphical outputs from this data. So what I have done, I've done some partial graphs here, which I kept open so that we will work on these graphs while we are working. Right now, I'm not looking at this. I'll come to this graph little later. The first graph that I want to plot is zone wise count. That is where I started with, right? Zone wise count. So this is zone wise count. A better way of presenting this is alongside the numbers. But if I don't like alongside the numbers, I can do something different. I'll show you how this graph came up. All I need to do is just select this, go to insert, and I click on bar graph. This is simple bar graph. Okay, so with these predefined tables already available, or I can still beautify it, the way I want to. Right now, just for the sake of time, I'm using this predefined. I can also go to quick layouts, more changes, the way I want to. What I want to do is I want to show you something. Let me first fix. Okay, so let's go with this. Okay, so these numbers are here. These are white, not visible. So maybe I'll have to select a different one. Let's select this. Okay. Now, when you put a graph, you have a lot of options, a lot of things. You can put axis. Right now, the axis is missing. You can put axis titles. You can put art titles. Right now, there is nothing. You can put data labels inside, outside, wherever you want. You see the data labels are changing. You can put callouts and data labels inside this, wherever. You can put data tables. So this is something that most of the analysts will do. Rather than putting the table on the top with the numbers, they will fix this data below the graph using this data table. So it solves both the purposes. Your table that you want to depict also comes along on the graph itself. It comes a data table. Let's explore more options. Axis title. So you can put axis title here. This is number of names. This is the legend. You can off the legend because we already have a legend here. You can delete this legend. It will beautify more. Let's see what else we can add. Data labels, we've done data tables. Error bars, you don't need grid lines. In case required, you can put grid lines. If you don't need it, most of the time we don't see grid lines on these graphs just for the beautification purpose. But if you really need it, you can. And then you also have an option of legends. You can even put trend lines. 10 lines here on this graph has no sense, so I will not any trend. So this is one of the graph that we do. And graphs. So another graph that I plan to insert is this one. Zone type, same type. So all I will do, I'll just copy this page data and I will put this data here. See what happens. Here I will have to do some modifications. I'll just plot it the way it is, and then I'll say what more I can do for making sense out of what I'm plotting. Right now I'm just plotting. Okay, so I just did this plot. This gave me that within the east zone I've got medical and travel, and these are the number of claims that are coming up on it. You can put data labels and also put data tables. Data table. So it gives me better understanding in one graph. That's one of the view that I can do. But I want to make it more better view. See what I will do. Okay, so what I'm going to do, I'm going to add a total against here. Is total for east zone, okay, which is 26. Total from north zone, which is 21. Total from south zone, which is 26. And total from west zone, which is 28. Okay. And then I will say what is the percentage of these claims. So East Zone medical claims contribute to 38% of the total claims from within this. Not overall. Okay, just understand this. This is not an overall percentage. This is only between this East Zone, North Zone, and West Zone. Is there a way I can do this graphically so that this output looks little bit more appealing, beautiful, and people can understand? And Excel has given us that power now. Chief, what I've done, I have just selected all of this. I go here, see all charts. Okay, and a lot of charts are coming up. I want to select a combo chart. I'll tell you why I'm selecting a combo chart. And I don't need this chart. I want a stacked bar. This is how a stacked bar looks like. So this is saying out of this how many. And then for percentage, I'm going to put a line graph. I'm going to put it on a secondary axis. I'm going to add another axis on this side. This trend percentage. Okay, and I click OK. I made one mistake here, but then that's okay. I should have done the total on the left and count on the right. I can still do that. Just a second. Will not have to make any change to the graph. Okay, I just reversed. So this is total. the graph gets automatically populated. And these are claim numbers. So I get a beautiful output which is showing that these were the claims that were received, out of which these many claims were paid, and this is the percentage of claims that are paid. I can again go select elements. I can data table. Percentages are reversed. Oh, sorry. Okay, second. I didn't realize that. Okay, it's fine. I can put a data label. Data table. And I can also put a labels. The data tables or data labels or both, depending on how easy it is for your readers to read through this. So this is also giving you a very good inside story about what is happening in your process. So it is giving you total claims for medical in each of the zones and what is the percentage of claims between the zones. I could have plotted paid versus received. So those are the other views we'll look at tomorrow.